Hey everyone, it's Sam. Today we're going to be talking about setting up a secondary as a hot backup for Postgres. We're going to be using streaming replication, and we're going to be setting it up using Kamal and Bash scripts. Um, the advantage of having a streaming replicant is to be able to do read-only queries and have something that you can fail over to in the case that your primary database has a problem. There's a lot of benefits to it, and those are just a couple of them. So let's dive in and figure out how it all works. Okay, so to understand how all this fits together, let's do a quick overview of Postgres and how data is written to the disk and how it works with streaming replicas. So how it works normally, obviously, is you have the client connected to the primary database, which is Postgres, clients being the Rails application or PSQL, etc. So it's connecting to the primary database, and you're reading and writing data directly from there. What the primary database does is when there's updates or when data is modified, the first thing it does is write it to this WAL write ahead log. And the write ahead log is used to record data and make sure that it's persisted to disk before it's available to the user. But the reason that we use the write ahead log is because it's more performant than individually writing to every DB file before returning, because Postgres uses a buffer cache, a shared buffer cache, so that data, when a user writes to the data, the buffer cache is updated automatically, which is in memory, so that clients reading again from that data can read very quickly without having to worry about flushing all this information to disk. But if you only store things in a buffer cache, then if the database were to die before the next flush to the actual disk, then you would lose all of that data. But what the write ahead log does is it allows the database to, if it crashes and comes back up, it can just read from the write ahead log. And it's more complicated than this, but this is just a very simplistic sort of overview of how it works. It will just replay every operation that has yet to be saved to the disk with the write ahead log. So having this write ahead log really makes it a lot easier for us to have a secondary, because what the secondary does is it just takes the data, reads directly from the write ahead log, and applies that to itself, giving you a one-for-one matching with the primary database and the secondary database. Now, there's a few different ways for the secondary to get the information from the wall. There's some where you're just syncing this data in between both, but we're going to be using streaming replication, which gives the highest amount of, or the lowest amount of lag time between the data being given to the primary database and the secondary database having that data available to you. We're going to add some modifications later to different things, so I wanted to give you just a little bit of an overview so that we understand and we're all on the same page about how this works. So let's dive into the code and figure out how exactly we set this up so that we can get this secondary replica working. Let's dive into the steps that we need to do to get this working. I set up a bash script here that's going to talk about every individual step that we need to do, and I'll show you how to update Kamal to get the secondary running and everything connected. So basically, really there's three steps, which is setting up the primary configuration, setting up the secondary configuration, and then bootstrapping from a backup. So we need to load the existing data that's already there onto the secondary from the primary, and then once that happens, the secondary can start reading from the wall, like we talked about before, the write ahead log. So this is just a bash script. I'll show you how it works. I'll upload it and then you can see how it works. And let's check out the Kamal config here. So this is just reusing the one I used, I made before for setting up Postgres and Redis. So you can check out that video if you haven't already to understand how to get Postgres set up. So we have our existing Postgres instance, which is right here, PG 16.1. And the only things I've added here are volumes for adding the configuration files. I want to be able to control the configuration, obviously, on the Postgres server, and I like to just see the file in its entirety when I'm building, as opposed to just modifying a few different things, as well as the HBA file, which handles the authorization and authentication for hosts trying to connect to Postgres. To get those to work, we need to copy them. There is a better, probably simpler way to do this, but for me, this is sort of like just the way that makes the most sense to me. It's maybe not the most beautiful way, but I like to look at it this way, so it's fine. We are mounting these Postgres configuration files from the etc directory, and we're copying them into the data directory. As much as I would like to just mount these individual files inside the directory, because of the way that Docker works, that's not possible. So we have the Postgres data, which is our named volume, which keeps track of all of the actual data. And then we have these individual files, which I'll show you in a second how we get them uploaded. We're going to copy them onto the existing host, and then that's going to be able to allow them to be mounted as volumes. But so we just copy them, the HBA file and the Postgres file, into the data directory, and then we just run Postgres as we would normally. This just reuses the Docker entry point file that the existing Postgres, the official Postgres image uses. So we have the main Postgres instance, which we haven't really modified much, other than we are now mounting our configuration file. We haven't changed it yet, but we're just mounting it so that we can change it later. And then we're creating a secondary instance. So like before, I'm not going to show you now, but you can look at it again. Go to Hetzner, launch a new instance, and get the internal IP address, put it in as the host, and set up the data again. So we're just going to use secondary Postgres data. We could call it Postgres data as well, but since it's on a separate host, but I like to just keep it separate, and my mind makes it easier. And the same thing here. We don't need to modify the HBA file, although you could do the exact same thing as we did in the primary to modify that if you want to change the authentication settings. And then we launch the Postgres command, exactly the same as before. So there's not much to do here. You need to run Kamal setup to get this new instance working. And I'll leave that up to you because I already ran it and it's just does exactly what we saw before. So let's go back to the setup file. So to set up the primary instance, we set a few variables here that make it a little bit easier to reuse some of the logic in the bash file. The data directory is where Postgres keeps all of this configuration. The hosts are the hosts that we set up in Kamal. The passwords, we're not using these at the moment, but I have them here just to make it easy to see. Secondary IP, primary IP, jump IP, which is what we SSH through, which we looked at before, and the database name that we're using, which is Simple Host Production. You can get the database name from your database.yaml file, the production database right here. So I had defined a few helper functions to run a command on the primary host using Kamal accessory exec. The reuse command here is used so that you reuse the existing container as opposed to launching a new one. I believe it would work without that, but that's fine. And then we have these SQL commands here, which we'll get to in a second, and the same thing for the secondary. So the first thing we want to do is uncomment this out, and we're going to copy the configuration file for the primary instance onto the primary host. As before, I showed you that we use a proxy jump box. SCP, which is secure copy, allows you to specify a proxy server to go through to copy this. So we're just doing that here with proxy jump on port 22, and we're copying this Postgres file, Postgres config file, and let's just pop in there for a second. The only thing we really need to modify, there's about a million things that you can modify on the Postgres configuration, but I'm going to try to focus really sort of tactically on the things that we really need to make sure that this works. Max wall senders, we want to be able to have it up to 10 processes to connect. This is the default, so we don't actually need to change this, but I just want to highlight that you need to change this in case you had set it to 0 or something before. And then max replication slots. So replication slots are what Postgres uses to keep track of who is reading from the write-ahead log. Before, without replication slots, you would need to keep track of the wall size. You need to make sure it's big enough so that it doesn't get removed or flushed to disk or whatever before the secondary instance had time to read it. And this helps with, in case like the secondary goes down and then it comes up, it can be really time consuming to have the secondary recreate its whole database from the ground up if it misses the wall, because if it misses a wall entry, then the database isn't in sync anymore and it's not really a good secondary. So what replication slots does is Postgres manages the wall size based on who's replicating, and to make sure that when a secondary is reading from the primary, it's not missing out on that. So that's what replication slots are. 10 is the default as well, but I'm just showing it for explanation purposes. So once we modify that and we copy that onto the primary host, we also want to modify the HBA file, which is the host-based authentication. So we can look at the config here. And this is pretty straightforward. The default config is up here. Some of this stuff you might want to modify, especially if you don't have everything locked down with firewalls, etc. But what I have here is we just use the host because we're using a host-based authentication. They're not on the same host. Replication, there's a special database in Postgres called replication, which allows you to, which the secondary connects to replicate. The user is called secondary. We're going to create that user in a second. And we want to be able to do this from the internal IPs. You could do this as just the secondary, but it's possible that maybe you want to set up 3 or 4 at once, and this makes it easier, but slightly less secure. So once all those things are modified, all we need to do is restart the host, which uses Kamal accessory reboot, which will stop the container, restart it, which means that the volumes will be mounted again. And if the volumes are mounted again, then it's going to reread these files and then restart with these new configuration options. So what else do we need? Well, like we said before, I need to run a command to create this new user. So we're going to call this person secondary, this role secondary with the password secondary password, which we created up here. My secure password, obviously change this to be whatever you want and something more secure than this. And then we run this primary SQL command, which is just me wrapping around the local PSQL command to make it like a little bit easier just to think about. And so that means that we are rebooting to reload the config, and then we're creating the role for the secondary user, and we just run this. The possibility is I like to be able to run the commands more than once, so I want to be able to run this script over and over just in case I mess something up. And so commands like create role will throw an error if the role already exists, which is fine, doesn't really matter to me. So I just catch that with the little bash or command here, and it just echoes user already exists because that's fine. And then the next thing we need to do is set up the replication slot. So on the primary, the replication slot, as we talked about before, keeps track of the wall entries that a secondary needs to read. So we just use the command, the built-in Postgres function, pg-create physical replication slot. You can also create logical replication slots, which we will talk about maybe some other day. So we run this command, and it will create a new replication slot for you to use, and we're calling this secondary as well. You're going to need these names later, and you could maybe put them in ems as well, or environment variables, or configs, or whatever you want, but right now I'm just copying them because they're all the same, and to me that's enough. Do that, and then we're going to go here. So that's all you need for the primary. It's pretty straightforward, especially if you're using replication slots. You don't need to worry about wall size, things like that. So let's go down to secondary server. Secondary server is also pretty straightforward. All we need to do is update the configuration a little bit to have the connection to the host and the slot name and something else. So let's just check that out. I put it in here as config secondary PostgreSQL. Let's check that out. So there's 3 things you need to do. Hot standby is optional, but I'll explain that in a second. The primary connection info, con info, is going to tell the secondary where to look for the primary. Pretty straightforward. Host is the host we're using, port, blah, 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 user, password, my secure password. Again, obviously update these to what you need. The slot name, which we called secondary, if you remember. And see right here, we call it secondary. And so we need to make sure that that name is the same here, which is secondary. And then hot standby. I like to turn this on, which allows you to run read-only queries from the standby server, which can be helpful for analytics and things like that. Save that. And once that's updated, we will need to restart the server. But we're going to need to restart the server again, so let's just wait on that until the end, and let's just stop it at first. So the reason we're stopping it is we don't need Postgres to be running at this moment. Actually, we don't want it to be running, because what we need to do first is bootstrap the data. And bootstrapping the data requires that we delete all of the files from the data directory and then run the command pg base backup. Pg base backup is a command for bootstrapping secondaries, as well as helping you with point-in-time recoveries, things of that nature. which maybe we can discuss in a different video. So how does it work? Well, we stop, we remove. This is using that command that I created earlier, and it's pretty, sort of dirty here, but I think it's easy to understand. The only problem that's hard to understand is these bash escape, because Kamal with the exec command expects the command to be a single string encased in quotes. So you can't just pass it a bunch of commands like you would on a normal bash script. So what you need to do is encase everything in quotes, and then if something is quoted inside of that, you need to escape the quotes. You might be tempted to use single quotes, but then you're going to run into some other problems, which is just one of the problems of using bash, because escaping strings, etc., is extremely annoying. So just remember, if you have a quote inside, you need to escape it so that it lives inside as a quote. So we're just running a command, which is remove everything from the data directory, and then run pg base backup. The host is the host that you want to get the data from, so that's the primary IP. The D, capital D, is the data directory where you want the new data to come into. Excuse me. User is the user we're connecting to the primary from, and that's going to be the secondary user that we created up there at the top. P just shows the progress. V is verbose, and S means for slot. So the replication slot that we created, we can reuse it actually for the base backup to signal to the primary, this is what we're using now. So don't get rid of these until the secondary comes online and reads from it. And so that's S secondary, and that's great. And then the last thing we need to do on the secondary is create this standby.signal file. This doesn't have to have anything inside of it. It's just for Postgres to understand that that it's starting as a standby. So Postgres reads this file, or tries to read this file, and if it exists, then it comes up in standby mode. If it doesn't exist, it comes up in primary mode. And then we just need to reboot the secondary host once all of this is done, and then it's completed. So once it's completed, we want to make sure that everything's running correctly, everything's up to date, and we have all the data. So we're going to run these commands. This one runs on the primary, and that's going to give us some stats about the replication. And on the secondary, we can see what's going on with the wall and making sure that everything is working there. So now that this is all set up, I'm going to run this, and I might speed it up a little bit because it can take a little while, but let's run it. So just one thing that comes up is we need to enter the password. It'll prompt the password for PG base backup that we set up before for the new role, which is called my secure password. And then that's going to start the PG base backup. As you can see, it's running. It's making sure that everything's there, syncing data to disk, blah, blah, blah. And it's all working correctly. So then it's going to start up the secondary server. And now we should be able to look at the logs of the secondary server, which is Kamal accessory logs, and then the name pg16.1/secondary -secondary. So let's check out the logs here. And we can see that it's running. It's running normally. And you can see that it's streaming the wall from the primary. Now, we can also do something here, which is run PSQL. So we're going to run PSQL to the secondary, and then we can run, let's turn this on. Let's turn extended display on, which is going to make it easier to read. And let's run this pg stat wall receiver command. Okay, status streaming, which is exactly what we want to see. This LSN is what is the wall's sort of unique identifier of different locations. Last message sent, everything is looking good for today. Slot name, everything is set up correctly. And then we can connect actually to the database, post production, and this is on the secondary right now. And we can do a count on this. I have these newsletter signups here, and it's 17. So now that's all working for the secondary. Now let's check the primary and make sure everything matches up correctly. So let's go back here, and instead of secondary, let's do primary, which is just this. And we're going to run this select all from pg stat replication, and select, I need to turn extend display on. And we're going to see right here that we have a secondary set up. The address is 0.5, which is what we're using, and everything seems to be set up correctly. There's a lot that you can do with tuning this. You want to add some monitoring to make sure that the LSNs are matching up. The LSNs are the wall IDs. You want to see how long the lag time is between the two. But right now you have everything that you need to have a hot backup. And so let's connect again to the SimpleHost database, production database. Oops, that's fine. And let's do that again. Select count from newsletter subscribers or signups. And we got 17. So we can see that it's using the same data, and the data is working correctly. So that's all you need to set up a hot backup with Postgres and Kamal. If you want to learn more about Kamal, there's a great book that I recommend below. There's an affiliate link there if you want to check it out. And if you want to hear more about Postgres, self-hosting, and Rails, please subscribe to my channel. Thanks.